Hello. Now we are going to look at listing all of the possible outcomes for probability type questions. So whenever we're listing outcomes in a probability setting, we're talking about a sample space. So the sample space is a word that we're supposed to know, or a phrase we're supposed to know, which is the list of all possible outcomes. So if we're looking for all of the things that could possibly happen, then we're looking at the sample space. And there are a few different ways that we can describe the sample space. The first one is just to write a list. And that's the first one we're going to look at. The other ones we're going to look at are diagrams to help us create the list. So if we look at the example of rolling one die, one six-sided fair die, and flipping one fair coin. What we want initially is just to write down the sample space as a list. So what could happen? Well, we could roll the die and we could get a 1. And when we flip the coin, then we could get a head on the coin. So an outcome that could occur would be that we'd get a 1 on the coin, a 1 on the die and a head on the coin. Or another thing that could happen is we could get a 2 on the, die, and we could still get a head on the coin. Or we could get a 3 on the die and a head on the coin. And we can do all of the situations where we get a head on the coin. And in this way, we can see we're doing this very systematically. In this way, we don't miss anything. If we just started writing down random combinations, so we could get a 5 in a head and then a 3 in the tail, the chances of missing something are very great, particularly if the question gets any more complicated than this. So ordering things, keeping the structure of things is very important to not making a mistake, particularly under exam pressure. So we start at 1 on the die, then 2 on the die, then 3 on the die, then 4 on the die, and we're going to deal with all the situations where we got a head in the coin. And then we go and we say, well, I could have gotten a 1 on the die and I could have gotten a tail on the coin. And then I go through all of them. And now we have all of our possible outcomes listed. There's nothing else that can happen. For probability questions, unless they specifically state it, nothing strange can happen, like the coin can't land on its edge or something like that. We just deal with what we consider in the question to be the normal outcomes of a situation. Now, if we look at our sample space here and consider a follow-up question, what are the number of possible outcomes? Well, this is one outcome, this is a second outcome, this is a third outcome. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible outcomes. Is there a way that we could get that answer without having to write out the sample space? Well, there are 6 possible outcomes for getting a die. And there are 2 possible outcomes for flipping a coin. So there are 6 possible outcomes for my first thing, and there are 2 possible outcomes for my second thing, and it turns out there are 12 possible outcomes if I'm looking for the combination of the 2. So that works in general. I have 6 possibilities for the first thing and 2 possibilities for the second thing. So in total, I have 6 by 2 is 12 possible outcomes. You can think about it in a bunch of different ways, but I've written it out here in a way that may prove illustrative. For each outcome that you can get on the coin, you have all of the possible outcomes that you could get on the die. So we have one of the possible outcomes on the coin with all of the possible outcomes on the die, and then the other possible outcome on the coin with all of the possible outcomes on the die. So this is why we end up multiplying. We must have 2 6s worth of possible outcomes if we think about how the sample space would get produced. So this is where our very fancy sounding name for this, we have the fundamental principle of counting. And it's connected to how we describe multiplication in general. But for our purposes, the fundamental principle of counting is the idea that if we have a particular number of outcomes for one thing and a particular number of outcomes for a second thing, the combination of the two would be the two number of outcomes multiplied together. So this is our way of listing the sample space, and this is a quick way of finding out the total number of possible outcomes. Now let's have a look at a way of, or two ways of visualizing our sample space to help us pick apart questions, particularly more challenging questions, more easily. So these are problem-solving tools that make diagrams out of this, because even for a fairly small question like this is a complicated looking list of things. Whereas if we can draw a picture that effectively describes it, it's a lot easier to get a feel for what's going on. So a tree diagram works as follows. You start out having not made, no outcome has occurred. So here, no outcome has occurred. One of the things that could happen when we roll our dice, which is going to be E or D, and I will make that branch up a little bit further. So we could get a 1 on our die, or this is a kind of a separate possible path for reality. We could get the 2 on the die, or we could get 3 on the die, or we could get a 4 on the die, or we could get a 5 on the die. Ooh, dear. Or we could get a 6 on the die. So those are all of the possible things that could happen with the die, and we draw our arms out to say we start out here and there's nothing has happened yet. Then when we roll the die, any of these 6 things could occur. And then we say from here, so we've rolled the dice and we've gotten to one of these possible outcomes. And then from there, we flip the coin, which I'm going to call C. So in this part of our tree diagram, we're dealing about flipping the coin. And for each one of these outcomes, you could have gotten a head or a tail, or a head or a tail for all of them. It's important to try and keep this as neat as possible. You don't want, if I do it wrong for a moment, you don't want to have it, you have a head and tail here, and then you have a head and tails out here. Keep all of the arms out the same length, keep everything neat. This diagram is supposed to help our thinking, and if it's all muddled and all over the place, it becomes very hard to follow, and it doesn't do its job for us. So we want to keep everything as neat and together as possible. So we have all of our outcomes listed. So in this particular situation, I started out, I rolled my die and I got a 1, and then I flipped my coin and I got a head. Or in this situation, I rolled my die and got a 3, and then I flipped my coin and I got a tail. So here I would have gotten a 1 and a head, and here I would have gotten a 1 and a tail. And here I would have gotten a 2 and then a head, and a 2 and a tail, and I'll fill all of them in. And we have our sample space listed out again, but this time we had a structure to follow to visualize the story of how each one of these things happen. That we got a 4 on the die, and then we went and we flipped the coin and we got a head on the tail, and that gives us a 4 on the die and a head on the tail. And these are very useful diagrams, particularly when we get into more advanced probability work. But for now, they're useful for making sure we don't miss anything in a sample space. And a two-way table is another way of doing the same job. Tree diagrams are more versatile, but if you have a fairly simple question like this one, a two-way table can be helpful. The problem with a two-way table is it only works well if you have 2 things that you need to keep track of. And with probability questions, you can end up with more than 2 things to keep track of, or more than 2 options to deal with. So what we do is we pick a two-way table. It's a table that goes in 2 directions. So we have our die is going to go across. So we write down the options for our die. We could get a 1, a 2, a 3, a 4, a 5, or a 6. Those are all of our options for getting a die. The other thing that we could have is we could have our coin. So our coin is going to be over here. And on our coin, we could get a head or we could get a tail. So going downward, I have the options for my coin, and going across, I have the options for my die, for my dice. So here, I would have gotten a 1 on the die and a head on the coin. So you read this like you would coordinates or a grid on a map. So 1 and a head is what we got here. Here we got a 2 and a head. Here we got a 3 and a head. Keep the order of these the same. So if the die number comes first, always keep it going first. And here we have 4 and a head, 5 and a head, and a head. And 6 and a head. Here we have a 6 and a tail, and we fill it in. And again, we can see we have produced our sample space. The only thing that catches people out, and you can actually see it caught me out here, you need to make sure you leave enough space to the left so that you can comfortably write your groups for your up and down number, in this case our coin that we are flipping. And you can see we produced the same list as we did before, but again the grid gives us a structure so that we don't miss anything. Now let's do an example. A dinner menu has 2 starters, 3 main courses and 2 desserts. How many 3-course meals are possible? So I have 2 options and 3 options and 2 options. So in total, I would have, so I could get the first starter and the first main and the first dessert, or I could get the first starter and the first main and the second dessert, and so on. So how many possible outcomes would I have in total? Well, I would have 2 starters by 3 mains by 2 desserts. I would have a total of 12 possible outcomes. So those are all of the outcomes that are possible, or 12 possible outcomes. And again, you get that by simply multiplying up all of the different individual numbers of possible outcomes. And that's our fundamental principle of counting. That's what that rule is called. Now, an extension to this would be, what would the tree diagram look for this? So what would the tree diagram look for this situation? This isn't what we were asked, but if we were asked, what was the tree diagram for this situation? Well, if I think about my starters, I haven't made any choice yet. I could have picked the first starter, or I could have picked the second starter. I'm actually going to draw them a little bit separated out, so this is easier to keep track of. So I've got my first starter or my second starter. That's my first choice made, whichever one I went for. And then from the main, I could have had the first main, I could have had the second main, or I could have had the third main. 1, 2, 3. Those are my 3 options for my main courses. And if I'd picked the second starter, I would have had those options as well. I could have picked the first main, or the second main, or the third main. And then from each of those situations, I could have gone for dessert 1, or I could have gone for dessert 2, or I could have gone for dessert 1, or I could go for dessert 2, and so on. And for some questions that we deal with when we have all of these filled out, they'll give us quite complicated stories, like how many of our options involved menu 2 and dessert 1. And you'd be able to see that there were 2 of our outcomes that involved menu 2 and dessert 1. And in that way, you can use these kind of diagrams to tell the story of the questions that we're asked. These visualizations help take quite complicated stories that they can give us and translate them into a visual that can help us to understand what's going on. So they're very valuable to get good at. And that's what we need for now.